Hi guys, so here's another kind of exam standard deviation question. Again, quite a similar format where it first of all asks you to work out the mean, then the standard deviation so you can get all the marks for this, and then finally you get a slightly different comparison question which we'll go back to at the end. So first of all, we've got our 10-pin bowling scores, 6 scores, and we're going to work out the mean first of all and then the standard deviation. So here we go. Again, I've done it all for you to show all the working. So our mean, we just add all the pieces of data together and divide by, there's 6 scores there, so we divide it by 6. So the mean for this first set of results is 116. For our standard deviation, again, if we go back to the formula, if you can't remember, hopefully you can get the formula and it prompts you. So the first thing you need to do is list each piece of data, your x values, take the x bar away from it. Well, the x bar is just the mean we've worked out up here. Then you're going to square all of those answers. Then you're going to sum them. You're going to add them together. And that's exactly what I've done in this table. So just be careful. And for this table, I certainly got a calculator and I worked across the page so that I didn't make mistakes because they're a wee bit awkward. So taking 116 away from this gives me minus 18. When I square it, I get 324. 102 take away 116 and so on. When I square it, this whole column should only have positive numbers once I've squared them, which it does. I've done my little double check and this column adds to 0, which is what I'm expecting. So now I've added all of these and I checked them a couple of times on my calculator because I didn't want to make a mistake here, and I'm pretty sure now that that's the correct answer. Okay, then I transfer that into my formula. So that's the top line sorted. N, remember, in our formula is the number of data. We started off with 6 pieces of data, so I've really got n minus 1 here, which is just 6 minus 1. So in my calculator, I did 1334. I divided it by n minus 1, 6 minus 1. So I divided it by 5 and I got my answer, and then I got the square root of that answer and it came out as that. And you can see I then just listed it and I looked at the second part of the question, and again the standard deviation was only to 1 decimal place, so I just did that the same, so I rounded it to 1 decimal place. Okay, now the second part of the question was quite an interesting one which caught a few candidates out because it's not the standard make statements or make 2 valid comparisons. This time it's got a list of statements and it's asking you to consider whether these statements are true or false. So again, for me, the first thing I've done is I've listed the kind of 2 comparables. So match 1, this is what we've worked out using our standard deviation formula and our mean, and then we're given this information. So for match 2, the mean of 116, the same as this one, but a different standard deviation, a slightly lower standard deviation. So let's go back and compare these, okay? So when you look at these 3, the first 3 really are talking about the total scores. So they're all talking about the same thing, and then 4 and 5 is talking about the spread of the data or the consistency of the data is another way to think about that. So really these are to do with the standard deviation, and this stuff here is to do with the mean, okay? So the total of the scores is the same in both matches is the first possible thing. Now, the way we know that to be true or false is by thinking about what the mean tells us. So we don't know the scores in the second match. Okay, we know that we've got 6 scores in the second match because the question tells us that. We know that the mean is 116. Now to get the mean, we had to take all 6 scores, we don't know what they are, we had to add them together, and then we divided by 6, and that gave us a mean of 116. So that means that even though we don't actually know what the scores are for the second set of data, we know that they added up to the same thing that when it gets divided by 6 comes to 116. So actually that must be the same as the first set of data because they had a mean of 116. So the total of the scores is the same in both matches. I would agree with that. I think that one's true. Okay, then the total of the scores is greater in the first match. Well, that can't be true, or the total of the scores is greater in the second match. So I would argue that the other 2 must be false. Okay, so even though we didn't know what the 6 scores were, we know that whatever they added up to, when we divide it by 6, it comes to 116. So it must have been the same total as was in the first match, okay? For 4 and 5, in the first match, the scores were more spread out. In the second match, the scores were match, the scores are more spread out. So it's which one are the scores more spread out. So if you look at the standard deviation here is bigger. So that is the one where the data is more spread out or less consistent. Okay, so it's match 1 where the scores are more spread out. So you've just really got to look at that and compare. So in the first match, the scores are more spread out. Yes, I would agree with that. So that bit's true, and therefore it can't be true that the second match the scores are more spread out because they've got a smaller standard deviation, so they're actually closer together. So even though the team on average performed the same in both matches, they performed more consistently. Their scores were closer to the mean, and they did a bit better therefore in terms of consistency there. Okay.